Hello guys, welcome to my channel. You're welcome to Master Builders Online Academy, the only online academy where you can learn all the principles and the boundary conditions that will help you gain mastery over major calculation problems. Yes, you heard me right. Most of the complex problems that you'll ever see, you'll ever encounter, whenever you come to this channel, you get them demystified with ease, applying principles that works, right? So in this module, I'll be showing you again exactly how to demystify complex Fourier series. Remember, in our last class or in our last lesson, we did talk about Fourier series, right? And then we talked extensively on the concepts of analytical description of Fourier series. Remember how we were analyzing graph, deriving f of x and the period for each of those functions. So in this particular video, guys, I'll be teaching you exactly how you can solve complex problems on Fourier series effectively without missing any step. Alright, so in this video, I'll be showing you how to solve problems on odd functions, how to solve problems on even functions, how to solve problems on neither odd nor even functions as related to Fourier series. These may be the major issues you have been having on this topic. But guys, the problem to whatever challenges that you are having on this course has come to an end. Having me to take you this topic today is already an edge to gain mastery over this course. Another thing you're going to be learning in this module is that you're going to be learning how to calculate percentage nth harmonic, like percentage 10th harmonic, percentage 4th harmonic, percentage 5th harmonic, percentage 7th harmonic, and so on and so forth. Again, you're going to be learning the concepts of even function and odd function theory. We call it the theory of even functions and odd functions. Then finally, I will be exposing to you, I will be opening your eyes again by showing you and teaching you how to unravel the mysteries behind half-range series and half-range cosine series. Yes, half-range sine series and half-range cosine series. Now, guys, if you are new in this channel, let me blow up your mind. All you need to do now is to go to this description below and check the link to the first lesson that we had on this particular topic. What you learn there are things that will power your mind enough to receive what we are going to be looking at in this lesson. So this lesson is a continuation class. So if you have not watched the previous lesson, kindly slide to the description below where you will see the link to that particular lesson called lesson 1. And in that lesson, we explain in details the analytical description of Fourier function, Fourier series, and periodic function. We solved about 5 examples. Is that not mind-blowing? Now, in this module, we'll be solving complex problems. But get it clear that any part of this video should not be skipped. Yes, it's actually for your own good. So, while you start watching this video, ensure that you do not skip any part of this video. Why? This is because every part of this video are encrypted with principles that works. Remember, as I do always tell you guys, that when you understand principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. So I will be showing you the boundary conditions and the principles that will help you gain massive mastery over this course. So therefore, I urge you never to skip any part of this video. Watch it from the beginning to the end, and then if you have any question, slide to the comment section and make your question or questions known to us. We will answer your questions to your own satisfaction. If you are ready for this mind-blowing session with me, shall we jump into the marker board without further ado? Lest I forget, don't forget to like this video, don't forget to share this video, and don't forget to give us positive comment. Now, on the board, we have Fourier series for a function of t, or a function of period t, right? A periodic function, a function of period t. Now, one of the things that you need to understand about Fourier series is that you really need to understand what Fourier series is all about. And in that first module, we did explain what Fourier series is all about. We defined Fourier series, we defined periodic function. Lest you forget, let me quickly remind you again what Fourier series is all about. Remember, Fourier series is the expansion of periodic functions in terms of infinite sum of sines and cosines functions, which are what? Trigonometry. Okay? Fourier series is the expansion of periodic function in terms of infinite sum of sines and cosines, which are three functions. Remember, infinite sum means it is continuous. So there is no ending. No ending. So the first thing we are quickly going to do now is for me to unveil the necessary formula, the necessary models, then the necessary equation that would help you solve problems on Fourier series effectively. Generally given, the Fourier series of any function is given as f of t is equal to 1 over 2 a naught plus sigma n equal to 1, 2, 3 t infinity. So you have t infinity here, and then we open a bracket, an cos n omega t plus bn sine n omega t. So this we will call equation 1. What we have on the board is called the general equation, the general model, or the general formula for a Fourier series. So whatever question you are given to address in Fourier series, maybe you are asked to find the first 3 non-zero values, the first 5 non-zero values, the first 10 non-zero values, as the case may be. This is the equation that you require. Alright? This is the equation that is required. Where an, okay, where a naught, an, and bn are Fourier series coefficients. Alright, so these are coefficients. A naught, an, and bn are Fourier series coefficients. Okay? Now, when we look at this model, this is A, standard. Starts from 1, 2, 3, 4, 5, 6 till you are able to obtain the range or the values within the range you are asked to calculate for, right? So, till infinity. 1 million, 2 million, billions, trillion, as the case will be, but to infinity. This is the limit here. Alright, then we have cos n omega t. This t defines the function, meaning f of x, f of t is equal to maybe 3t squared plus 4t minus 3. Okay, so the function will be in terms of t. Now, take for instance, as you are given this, the function is the function of x 3x minus 4. Take for instance, this is what you have. That means when you are stating this formula, anywhere you have t, you will replace it with x. So it doesn't mean that you must use x or 2. So if the examiner, for instance, gives you the function or the periodic functions in terms of x, like we have now, that means when stating this formula, this guy here will no longer be t, but will be x. This guy here will no longer be t, but will be x. And this guy here will no longer be t, will equally be x. This is the general model for solving any problem on Fourier series effectively. So the question is, what am I actually interested in obtaining? Remember from the definition, we did mention that it is an expansion. You look at this here, an expansion of periodic function in what? Terms of infinite sum of cosines and sine terms, right? So this is the cosine part of it, and this is the sine part of it. And as you can see now, you have n here, which shows that from n to 1, n equal to 1, n equal to 2, n equal to 3, n equal to 100, n equal to 1 million, n equal to 2 million, n equal to 10 million, just like that and so on, that you can have a continuous value for cosine functions and also for the sine function. But the big question is that, is it every problem that I am given that I will always make use of this big or this giant equation? Certainly not at all. Not at all. So this is where the theorem of even and odd function comes in. Are you with me? So this is where the theorem of even and odd function comes in. Remember, I did mention that I will first of all state the formulas, then before we now start analyzing the concept of the theorems of even and odd functions. So even functions and odd functions helps us to reduce this equation to a little minimal level that will help us solve problems on Fourier series effectively. Remember that anytime a function of x or a function of t is given, most often the time in Fourier series, it either falls out to be odd function, falls out to be even functions, or fall out to be neither even nor odd. So it is when it is neither even nor odd that you make use of this equation. When it is neither even nor odd, this is when this equation is used in general. But what happens if the function is an odd function? What happens if the function is an even function? Something will go out of this model. So let's start looking at this aspect. For odd function, for even functions, okay, for even function, Bn is equal to 0. Remember, I will state the formula for all of this, okay? So Bn is equal to 0 anytime you are dealing with even function. I will tell you how to know that a particular function that you are given is even, is odd, or is neither even nor odd, alright? But that's not the major problem now. The major issue now is to look out for the formulas. Then later I will now examine how to identify even function, odd function, and then neither even nor odd. So this, in this case, for every even function, Bn will always be equal to 0. Bn is always equal to 0. Remember that Bn is what? A coefficient. So when Bn is equal to 0, when you put in 0 here, this term of sine becomes 0. So you will be left with cosine terms only. So it dawns on you now that anytime you are dealing with even functions, only cosine terms are present. Only cosine terms are present anytime you are dealing with even functions. I hope I begin to blow up your mind already, right? Now follow me up. So in this case now, this model will have become f of t is equal to 1 over 2 a naught plus sigma n equal to 1, 2, 3, just like that, then infinity. Now an cos n omega t. This becomes our equation. So when you find out that a given function is even, then you apply this equation. That means you only require to calculate A naught and an. But what happens when the function turns out to be an odd function? Follow me again. For odd functions, a naught is equal to 0 and an is equal to 0. So for every odd function, both a naught and an are equal to 0. So now, guys, let's come to the general equation. In equation 1, if I put in 0 here, it shows that this term will not exist. Then when I put in 0 here, when I multiply cos by 0, therefore everything here will automatically become 0. So I will be left with Bn sine n omega t. It shows that for every odd function, only sine terms exist. Cosine terms doesn't. Are you there? So only sine term exists, but cosine term does not exist for any odd function. Remember, I promised you to show you exactly how to identify odd functions and how to identify even functions, right? So follow me. So in this case, this equation would have turned to f of t is equal to summation infinity n equal to 1, 2, 3 as the case may be. Then we have Bn sine n omega t. This becomes equation 3. So you see now, this term will automatically become 0 and this term will also become 0. So just understand now that anytime you are dealing with odd functions, this will become an equation to solve for it. Then when you are dealing with even function, this is the equation. Then when you are dealing with neither odd nor even function, then this becomes the standard equation. So in this video, in this module, guys, I'll be showing you exactly how to solve problems using this equation, how to solve problems using this equation, and many other equations. So from here, guys, these are the 3 major equations that are required to solve problems on Fourier series effectively. So now the question is, if I am to find Fourier series using equation 3, the only thing I need to calculate for is Bn. If I am to calculate Fourier series, also for Fourier series functions using equation 2, then the only thing I need to calculate for is a naught and an. Now the question is, how do I calculate for a naught, an, and bn? Remember that they are the Fourier series coefficients, and these are the only thing that you calculate for. Okay, so how do we need to do now? We now begin to analyze how to find a naught. So a naught is given as 2 over t integral of t over 2 minus t over 2 f of t dt. This becomes our equation 4. So this is what we have, t over 2 to this. Now this is where the concept of period comes in. Okay, so it's starting from negative half of t to positive half of t to complete one cycle. Now I will explain the mystery behind this later on, but let's deduce all the equations. Okay, now the next is, how do I obtain an? When we move here, an is given as 2 over t integral of t over 2 minus t over 2 f of t cos n omega t dt. This becomes equation 5. We have this as our equation 5. Then the next we have to do is for Bn. Our Bn is 2 over t integral of t over 2 minus t over 2 f of t sine n omega t dt. This becomes our equation number 6. So you find out that anytime I need to obtain the value of a naught, I'll make use of this equation. Anytime I want to obtain the value of an, I'll make use of this equation. And finally, when I want to obtain the value of bn, I will calculate for bn using equation 6. But the big question is that for every Fourier series that I'm given, must I calculate for all the coefficients of the Fourier series? Not at all. Not at all. What you calculate for is determined by the function that you are given. This is why the theorem of odd functions and even functions is very, very important to help you solve problems here effectively. Now look at it. If I find out that the function that I'm given or the problem that I'm solving, either from a textbook or being given by an examiner, is an odd function, therefore I will use this equation. Because I am using this equation, the only coefficient that is present here is bn. So that means if I am solving for odd function, there is no need for me to calculate for what? A0 and an, because if I do, I will still have the result as 0. So there will not be need for you to start stressing yourself in an attempt to solve for A0 and an. I hope you understand that. So even though they are not supposed to give you 0, or if peradventure they might not give you 0, as long as you have been able to identify that you are solving for odd functions, and as a result, this is the formula required to calculate for each Fourier series which contains only sine term. It therefore means that there will not be need for me to calculate A0 and an because they are not part of the model, the formula, or the equation that is required to calculate for what the examiner requested for. Period. Then the same way, if I find out that the given function I am addressing at the moment is an even function, then I will first of all step the equation for an even function. And when I have this done, guys, I will come here and check for an even function, which is equation 2. I only have A0 and an. Haven't been told that bn is equal to 0, right? So in this case, it shows that calculating for bn won't be necessary at all. Not at all. It will not be necessary. Are you getting it, right? I hope you are getting it. So it is not necessary at all. I don't need to calculate for it because even though I do, guys, by standard, I will still have this. You will still have this. So there won't be a need for you to start calculating from bn. So one of the things you need to do is that once you ascertain the function that the given function is, all you just need to do is to pick the equation for that function and then calculate for the coefficient of Fourier series that is present in that model. I hope you are learning something in this model. I hope you are gaining massive values watching this content, right? Now let's continue from here. So having stated all of this formula, what are the necessary equations again that is needed? We need the equation for omega, which is angular velocity, and this is given as angular velocity is given as 2 pi over t. This is the equation. So we can possibly call this equation 7. These are the equations that I need to solve for any problems as far as it has to do with Fourier series. But now, the next question is, I did mention that in this module, I will be showing you again the concept of obtaining a percentage end harmonic. So let me state the equation for that as well, so we progress bit by bit. Now we have percentage end harmonic. This is given as Bn over B1 multiplied by 100%. So we will call this equation 8. So guys, anytime you are calculating for percentage end harmonic, this can be 5th, 7th, nth. This n can be any number. It can be 5, it can be 6, it can be 10, it can be 11. So you can be asked to find percentage 10th harmonic. So this will now become B10 over B1. If you are asked to find percentage 5th harmonic, this will be B5 over B1. So it is the ratio of the required number to the initial number, which is B1. Are you here? So the question is, how do I find Bn? there is also a module to find Bn. Now, by extension, Bn squared is given as An squared plus Bn squared. Automatically, Bn will be square root of An squared plus Bn squared. So this becomes equation number 9. So this is how you calculate for Bn. Now, so guys, you find out that this A here and this B here represents the Fourier coefficient. Alright? Fourier coefficient that we have. So if I have here as 3, everything here will be subscript 3 or 3. If I have here as 5, everything here will be subscript 5 or 3. But remember that this equation 9 only exists fully as it is now. All the 3 terms here exist only when I am dealing with equation 1. If it happens to be equation 2, for instance, which is for even function, like we have it here now, where Bn is equal to 0, it shows that there is no need for Bn, or you can just put in 0 there without calculating or without stressing yourself. Okay? So that means if this is B8, this is A8 squared, then this is B8 squared. It shows that whether B8, B10, B50, B60, as long as it's an even function, this will be 0. Because all values under even functions will be 0, irrespective of the number. Are you there? So the same way, if we find out that it is an odd function, then An will be 0. Because we did mention that A0 and An, they are 0. Remember, we are using An and Bn. No A0 here, right? So this will be 0. That means only this will exist. This is just all about the concept of Fourier series analysis. But one thing that is left now is, I did mention equation 1, 2, 3 are the major vital equations that you need to solve problems on Fourier series effectively. While all of these are how you can get values to fill this equation, fill this or this, depending on the function you are given. So now the big question now is that if I am given a function, how do I get to know that this function is an even function or is an odd function? Very, very big, very, very important. Now understand that for every odd function, if I find minus x, if I find a function of negative value, the result will also give me a negative end product. Take for instance, if you get your calculator and then find sine 30, you will have 1 over 2 positive. Again, if you find sine minus 30, you will have minus 1 over 2. It shows that for every odd function, if you put in a negative value into the function, the end product will be negative. And if we only put a positive value into the equation, the end product will be positive. So what you put in, the sign you put in, is what you will have in return. Garbage in, garbage out. So if I substitute negative value, my end product will be negative. If I substitute positive value, my end product will be positive. This is the theorem of an odd function. But this is not what we need to help us apply this formula. What we need here is that the graph of an odd function is symmetrical about the origin. This is the concept. Okay, then I will define that again. Then we'll do some practical analysis to that. Then again, if I have f of negative x and it gives me positive f of x, this is a graph, or this is what? An even function. For an even function, when you substitute a negative value, it will give you a positive value. And equally, when you put in a positive value, the end product will be positive. It shows that irrespective of the sign you substitute into the model, the end product for every even function turns out to be positive. Take for instance, we have cos 30. This will give us root 3 over 2 or 0.866, right? Then when we have cos negative 30, this will also give us root 3 over 2. Please, while you are watching me do all of this, get your calculator, so that you can try this out and confirm this all by yourself. Very, very important. This is the best way to learn. Okay, so you need to practice whatever I'm doing here. Okay, right away. Just get your calculator, impute these values, and verify this theorem for yourself. So anytime you put positive, it gives you positive. Put negative, it gives you negative. It is an odd function. But when you put in positive, it gives you positive. You put in negative, it gives you negative. Then it is an even function. So even function always end up giving you positive outcome, while odd function gives you depending on what you substitute. So if you put in positive, odd function gives you positive. If you put in negative value, odd function gives you negative. That's why it's odd. But for even, whatever you put in, the end product is positive. I hope you have understand this concept about this now. Now let me quickly show you the part that will actually blow up your mind to know whether you are using this equation or this equation, because there is something that we need that will help us validate very, very, very clearly whether we are using equation 1, equation 2, or equation 3. So how do I check for? How do I check for? How do I check for? I know you are anticipating for me to unveil this secret. Guys, if this content has helped you to this level, if you have been engaged enough to watch this video to this level, and you have not subscribed to this channel, you have not liked this video, kindly subscribe to this channel. This is the only way you can encourage us to do more. Subscribe, turn on post notification bell so that whenever we upload mind-blowing content, you will surely be notified. You won't miss out of our mind-blowing content. Make sure you don't forget to share this video to your friends and well-wishers. Again, let's come back. I want to show you the mystery behind identifying even functions and odd functions. Okay, guys, now look at this. For even functions, then odd functions. Okay? Now, in Fourier series, the part of even function and odd function that will give you a high level of stability is the graphical approach. Graphical approach. Graphical approach. Graphical approach. Okay? So now, for even functions, the graph of every even function is symmetrical about y-axis. Graph of an even function is symmetrical about y-axis, which is the vertical axis. While the graph of an odd function is symmetrical about the origin. About the origin. About the origin. So the graph of an odd function is symmetrical about y-axis, which is the vertical axis, while the graph of an odd function is symmetrical about the origin. About the origin. About the origin? About y-axis. Are you there? Now, how do we get this diagrammatic notation? Now, take for instance, this is xy axis. If I have something like this, let's say this is 2 points that we have, then I shade this, then I have another one like this, I shade. Remember that this is y axis, y this is x axis, alright? So now, you see that the values you have, if I cut this in y direction, what I have to the left of x is what I have to the right of x. Same triangle, right? When you cut this in vertical direction, cut it like this, look at the left, look at the right. What you have here is equal to what you have here. In the same way, it can also be any shape like a curve like this. It can be a curve. It can be a curve like we have it now. So not this part now, So this is what we have. They are at both at the bottom, right? This, if I still divide this in y direction, look at the right, look at the left. What I have at the left is equal to what I have at the right, standing vertically. Standing vertically. This is the concept. It can be any shape. It can as well be something like this. Maybe something like this. It doesn't matter. For as long as this is my y as it is, as I divide like this, what I have to the left is what I have to the right. Therefore, this is a perfect way to identify the graph of an inverse function. So what you need to do is that anytime you are given a function in Fourier series, the first thing you must do is to plot a graph for that function. What will the graph help you to do? The graph will help you to identify if it is even or odd. Are you there? Now again, so another thing I will show you here to make you understand this perfectly is when I have done this, then I will be able to show you this. Now for odd function, we did mention now that the graph of an odd function is symmetrical about the origin. How is this done? If this is y, let me have another one here, as is, then I have something like this. Then the other one will be somewhere here. This like vertical, remember vertically opposite angle. They are opposite each other, vertically opposite angle in different quadrants. Although these are in different quadrants anyway, but I will show you their basic difference. So this is y as is. So if I stand in y as is, what I have to the left is not what I have to the right. Why? One part of this value is at the negative section of y, the other part is at the positive section of y. But for this guy, both will either occupy the positive section of y or both will occupy the negative section of y. Are you getting that value? In this case, you see that both this is y. Everything is the negative side of y. Remember that if I have a graph this way, plus of y, this minus of y. For this, it is either both are situated at the positive side of y or both are situated at the negative side of y, irrespective of the shape. Irrespective of the shape. But for this guy, one of the value will be at the positive side of y, or the other will be at the negative side of y. I don't know if you can get it that way. So it can be any shape at all. It can be any shape at all. One is at the positive side of y, the other is at the negative side of y. So for this case, both are either at the top or both at the bottom. But in this case, one will be at the top, one will be at the bottom. I hope you are gaining massive values already. So these are the ways to check. So when you look at this now, this is the origin. So if I stand at the origin to look this way and look this way, it's symmetrical. But not when I divide it vertically. So it's only when I'm at the origin, I stand at this spot, that what I see here is what I see here, ignoring their signs and values. Okay, ignoring their sign, meaning when I mean sign, meaning negative or positive. So when I start at the origin, I see this way, I see this way, the same perfectly well, but not when I divide it in y direction. But in this case, if I divide it in y direction, it's symmetrical to x, it's symmetrical to what? Y axis. So understand from now that the graph of inverse function is symmetrical about y axis, while the graph of an odd function is symmetrical about the origin. The graph of an odd function is symmetrical about the origin, while the graph of an even function is symmetrical about the y axis. Then finally, we'll start solving problems now. So what do I really need to know in final conclusion to be able to solve problems here is that if you find out that the graph is an odd function, you already know the equation to use. If it is an even function, you already know the equations to use, right? Now this is not any more difficult to us. Again, now, so the question is, if I am given a question in exam, or I'm trying to solve problems at home, or whatever form of problem I'm solving on Fourier series, what is my first step to take? This is what I want to show you now. So the first step to take is to validate whether the function that you are given is an odd function, an even function, or neither odd nor even function. But as far as this your level is concerned, we are limited to odd function and even function. It shows that there will not be problem given where you will need to apply this theorem here, this equation. So we will either use this equation 2 or equation 3. So if we are using equation 2, we need only equation 5 and 4 to fill in for equation 2. Then if we are dealing with equation 3, which is odd function, we need only equation 6 to get the value of Vn, right? So you don't use all the equation. I hope this is making sense already. So for odd function, I only need equation 3 and equation 6. But for even function, I need equation 2, equation 4, and equation 5 to fill in for the space of A0 and An. This is how these guys are treated. Then finally, we have what we call half range sine series and half range cosine series. So now, what's the difference between half range sine series and cosine range series? What's the difference between the two? For half range sine series, the formula you will use for this, you don't need graph here. So when you are given, you can be asked by the examiner or in textbook, wherever you are or whatever you are doing to solve problem on this course, on this topic rather, is that if you are asked to find half range sine series, it means that this period, this function, will only be a function of sine. All the terms will be sine terms only. There will not be cosine term included. There will not be. So for half range sine series, it is what? An odd function. This is the only model for Fourier series where you have only sine terms. So this one makes it easier. So if examiner asks you to calculate half range series, it means you are dealing with an odd function. You get that? God. I'm mind blown already. Mind blown. Higher. I'm blessed. So now look at it. Half range sine series is a series that contains only sine terms. And because it contains only sine terms, I will look for the equation that contains only sine term. And that equation is equation 3. This is how I find the function of x. Find half range series. Then if I find out that I am asked to find or calculate half range cosine series. Half range cosine series is a series that contains only cosine terms. And among the model to calculate for Fourier series, the equation that attends to this is equation 2, where I have cosine without sine. So it shows that if I am dealing with half range cosine series, I am indirectly dealing with an even function. So it shows that if I only solve problems on even function, solve problem on odd function, the same questions have covered this up already. Because when you know how to solve problems on even function, you have indirectly know how to solve half range sine series. And if you equally know how to solve problems effectively on all functions like we have here, then you equally know how to solve problems effectively on half range sine series. So understand that half range sine series is a series that contains only sine terms, and in such they are termed as odd functions. While half range cosine series are series that contains only cosine terms, and hence therefore they are termed as even functions. So guys, at this point, I think I have been able to explain, demystify the mysteries behind Fourier series. Solving problem here now wouldn't be an issue. So we are diving right away into solving problems. But before we do this, guys, if you are sure that there are things you don't know yet, please before you dive into the session where we'll be solving problems, ensure you go back and replay this video so that you get yourself equipped enough with these principles so far. Because when you know these principles, the problems you are going to be solving now will become child's play to you. I tell you the truth. They will look exactly as 100 terms and unit. Exactly like 100 terms and unit. Why? Because you know the principles. So go back and replay the video to this point before you will dive into that part where you will be dealing with the cosine terms. Now, I did mention that there is something I really want to explain, but I will do that while we start looking at problem number 1. I did mention earlier that I will explain the concept of this, right? I will explain the concept of this. In our next module, I will explain it. But in a short while, understand that if I have integral t over 2 minus t over 2, this guy is defined over a complete period. And I did mention this earlier that in our last module, we were talking about analytical description of Fourier series. And I told you earlier that if you have not watched that video, you have to go to the description of this video and check the link to lesson 1 there. Click on it so that you will watch that part. And if you cannot find it there, just go to our playlist session. You will see the topics one after the other. Check under Fourier series, you will be able to see lesson 1 and then follow up from there. Okay? So if this is what we have, this is defined over a period of time. Now, this can be expanded. Let's assume that this is a function of f of t. Okay? This is what we have. This can be defined as a range of minus t to, remember this is the lower limit. It can move from here to 0 first, which becomes f of t 1 plus then this guy here now becomes the lower limit to t over 2 f of t. So this is the explanation of this when you are given two functions. So it shows that if I am given two functions, I am supposed to solve for this, solve for this. But when you are given two functions, maybe you find out that it is an even function or an odd function. Instead of doing it this way, you don't need to do it this way. All you just need to do is to multiply any of these equations you are using by 2. Because whatever you will have here is what you will have here. So take for instance, I solve for this, I have 8. Then plus I solve for this, I equally have 8. This is 16. So instead of solving for this and equally solving for this, which will take me a very long time, I can simply say let this be what? Integral of 0 to t over 2, 2 times whatever I have there before, f of t. So if this guy will give me 8, then 2 multiplied by 8 will give me 16. Are you getting it? So in this case now, the problems you are going to be solving will include us to solve problems within a particular period. And as such, we'll be given 2 functions, 3 functions as the case may be. So when you are given series of functions, you're supposed to solve it this way. The first function, solve it, get the result. Solve the second function, get the result, then add them up together to get whatever integral you are looking for. The same is applicable to this and this. That's how you're supposed to do it. But because you find out that it is even function or odd function, all you just need to do, pick one of the functions, multiply it by 2, because when you solve for both, you are going to have the same result. And when you add them together, it is the same thing as taking one of them, multiplying it by 2. I hope I've been able to explain this concept very, very well. So without further ado, let's dive into that part where we'll be solving Fourier series problem under even functions. I love you guys. See you in that class. Wow, hello guys, welcome to this session with me. I will show you exactly how to solve this problem on the board step by step. Earlier on, I told you that we have lesson 1 on this module, and in that lesson, we solved question 1, 2, 3, 4, and we stopped at 5. Okay, so this is a continuation class, and then we have question number 6, like you saw before this current page. Okay, now in question number 6, we are asked to determine the first 5 non-zero terms of the Fourier series for a periodic function defined by this. Get clear. What is the question? First 5 non-zero terms. That means there are terms as you solve that will actually turns out to be zero. If you have actually solved problems on Maclaurin series before, you will understand this. If you have solved problems on Taylor series, you will equally understand this. Other sequence. Are you there? Other sequence and series. Advanced aspect of sequence and series. You will see that when you differentiate over time and begin to substitute the value of x and value of y as the case may be, most importantly for Maclaurin series, when you keep substituting 0, at some point you have values, at the other point you have 0. As you continue, you have values, you have 0, you have values, just like that. Then, after solving for a particular number of time, you now select particular values and then ignore the ones that are 0, right? So the same thing is applicable here. So we are asked to find the first 5 non-zero. So that means some will definitely give us 0. So it is not the first 5 problem we solved or the first 5 coefficients we solved for, but the first 5 non-zero. That means before we can get this first 5 non-zero, we may have solved up to like 8 times or 8 coefficients before we get this. We can as well solve for just 5. But one of the things is that since we have first 5 non-zero, it means that there are certain coefficients that will give us 0, either even or odd. Okay? So now, what are the functions? F of t is equal to 4 plus t. Within what range? Remember, this is one of the reasons why you need to check the description to watch the video we had before this one, lesson 1. Okay? So you'll be able to understand how come about this. These are the limits, which shows x1, x2 the other time, right? That means this is t1, this is t2. So this function is defined within a range. And I told you that there will not be periodic function recorded if there is no change in the value of x, which is the horizontal axis. Alright? So these are the two values, and this is the function of x that we have there. And now these values are given in terms of t, or these functions are given rather in terms of t. Okay? Now, then the second function is also given within 0 to 4. Then we are now given the period. F of t is equal to f of t plus 8. So this value you have here now serves as your period. Now again, peradventure you are not given period. How do you get your period from the functions that you are given? Take for instance, this one is not given at all, this line. This third function is not given. From here, all you need to do is to ignore this sign, pick this first value, from this value to this would have given us 8. So add the two values together. That will give you 8. That's the period. So peradventure, you are not given the period. The period is already covered within the first value here and the last value here. So it is from negative 4 to positive 8. Take for instance, I have something like this. So this is 1, 2, 3, 4. Minus 4, minus 3, minus 1, minus 2, then minus 1. Then this is the origin. 0. I have 1, 2, 3, then we have 4. So if I count now, 1, 2, 3, 4, 5, 6, 7, 8. Okay? So you have 8 periods. So from here, for me to have a complete cycle, I have to move from negative 4 to positive 4. If you understand number line very well, I think this will also be an added knowledge. Okay? That's clear for that. So we already were given the period. Now, second question. Remember there are two questions in one. A, determine the first 5 non-zero. Now, number B now said that we should calculate also if percentage third harmonic. Third harmonic. 3 third harmonic. That we have it. So we have our solution. This problem is it hard? Kind of. Not hard. Using those principles earlier, you are good to go. If you are not good without those principles yet, go back and replay the videos. If you are good, let's move on. Now, the first thing we will do, like I told you earlier, to solve any problem on Fourier series effectively, is that you must first of all determine the nature of the function by getting to know whether the function is an even function, odd function, or neither. How do you get to know whether it's an even or an odd function? I taught this earlier before we started taking problems, right? I did mention, let me repeat it again, that to be able to ascertain whether a given function or functions will sum up to give you an even function or an odd function, you need to plot the graph. It is the graph that will show you whether it is an odd function or an even function. We say when the graph is symmetrical about the origin, it is an odd function. But when it is symmetrical about y-axis, it is an even function. So let's check out for the graph. This is the first thing you will always do. Okay, now let's go. So now the first function is f of t given as 4 plus t. At what range? At minus 4 less than t less than 0. And I did mention that this is t1 and this is t2. And remember, for us to have this before in this function, we always have a line whereby whether horizontal or inclined from lesson 1 again, where we have here as t1 and here as t2. Remember that y will also have two values. It will have value here and have value here, right? Whether inclined or horizontal. And I show you the mystery why you don't consider vertical lines in that video. So it's either you have this where the value of x change and you have two values for y, or this where the value of x change and then you have two values for y as well. So it can either be this or this, but we don't know whether it is this or this. But all we did know now is that this equation is linear. This can be linear, this can also be a linear. But most importantly, it's going to be a curve. For a horizontal line, there will not be a function of t or x. It will be just value. But for inclined, there must be a function of x or t attached. So that shows that this value we have here now will give us inclined values. Let's validate this. Okay, so it shows that now that I have gotten this, I have my t1, I have my t2, then I need to find f of x1, which is y1, and y2. So how do I get to obtain the value of y1? And how do I get to obtain the value of y2? So to obtain the value of y1, all you simply need to do is to substitute the value of x1, which is t1 now, into this equation. Get the value. That serves as the y1. Then put this other value here. Again, that serves as the y2. But remember that we did mention that f of t is the same thing as y. So I won't be using y, but I will be using f of t instead of y1 and y2. Okay? So now, this equation becomes f of t is equal to, so when the first value of t is -4, and we have 4 plus minus 4. Automatically, this will give me 0. Again, when I substitute in for the second, f of t is equal to 4 plus, what's the next value of t? 0. I put in 0 here, then this will have given us 4. So I've gotten the two values for y, just as I already have the two values of x. So this will help me to plot graph for this line. Okay? Then remember that lesson 1 we were given graphs, we are already given described graph for us to obtain the functions. But in this case now, we are given function for us to plot the graph. Hope it's clear. In lesson 1, we were analyzing graph to get function. But in this lesson now, we now need to analyze function to deduce the corresponding graphs. Right? Okay. So now again, we move to the next function. The second function is f of t is equal to t minus 4 minus t. Defined within the range of less than this, less than. So it shows that this is t1 again, and this is t2 for the second line. And for this line as well, I need to find y1, since I know x1, x2, which is represented by t1, t2. Then I need to find y1 and y2, which will be represented by f of t. You can actually use y1 and y2, it doesn't matter. Okay? But understand that this relationship covers a for y. Okay, if this is understood, so when t is 0, which is the first value, this will give us 4 minus 0, and this will give us 0. You can put it in bracket if you want to. Then we are done with this. So this will give us 4 minus 0 will give us 4. Then f of t is equal to, again, we want to put in the next value of t into this equation. We have 4 minus the value of t is 4. And 4 minus 4 will give us 0. So these 4 values here, 1, 2, 3, 4, will help us to plot one line. Remember, for each line, I have x1, y1, x2, y2. If this is line A to B. So these are the values I will use to plot this line now. Y, C to D, as the case may be, these are the values 1, 2, 3, 4 will be the values I will use to plot the next line. So since I am giving 2 functions, I have only 2 lines to make up my period. Clear? So what next do we do? All we simply need to quickly do now is to plot the graph with these values. How do we plot the graph? Very simple. All you need to do now is to draw a vertical line. It can be very faint. Okay, let's assume I own this place. Let's just do it here. Draw a vertical line. And horizontal line. Something like this. So this is our T. Then this is F of T. Why this point is the origin O. Okay? This is the origin. So what we need to do now is to check what are the values of x as given from -4 to +4. You are the one doing this. You can decide to label it 1, 2, 3, 4, 1, 2, 3, 4, or 2, 4 at any regular interval you want to use, like graph. It's just normal graph. Use 1 cm to represent 2 centimeters. Use 1 cm to represent 1 meter. As the case may be, 1 unit as the case may be. You can use it that way. You can decide to use 2 cm to represent 4. You are using your eye because we are not actually using graph here, but we are plotting graph on a plain sheet. So you can just use your eye gauge provided that you are able to get equal intervals. So I can say let here be 2, while here is 4. Although I don't have to. I can have 1, 2, 3, 4. It doesn't matter. It's just normal graph. Now again, this is -2. Then this is -4, just like that. You can have -6 just like that. But why I stop at 4 now is that the maximum value of t is 4 and -4. So whether you go more beyond this or not, it doesn't affect the values. Okay? We are done for x. What about y? For y, we have just 0 and 4. 0 and 4. So here is 0 already. We can call here 2 and call here 4. So this is our 4. This is our 2. Okay? For y, this is 2. We are being able to what? Sketch the coordinates. The next thing is now to represent our lines on this graph. So we start from the first function. For the first function, remember, when we have -4, when we substituted into this equation, the equivalent value of y that we had was 0. That means when x is -4, y is 0. In other words, when t is -4, f of t is 0. So this is -4, and this is when f of t is 0. So you mark it. That's it. It's just normal graph. Again, we move to the next one. When this guy is now 0 at the origin, when s is at the origin, what was the value of f of t? F of t is now 4. So you mark it. This is the 4. Okay? It's as simple as that. Then we are there. The next is we move to the second function. We are done with the first function. So we can draw the first line by connecting these 2 points. So this is the line for the first graph. You can decide to shade it if you want to. I hope you are following. Now that's it. Then we move to the second function. F of t is equal to 4 minus t. So the question is, how do I solve this problem? Very simple again. All I need to do is to start. When the first value was 0, meaning at the origin, when t is 0 at the origin, then the other guy is t4. So we are still marking these same points as our usual 4 position. Then when this guy is now 4, which is at this point now, this other guy becomes 0. Then you have this. That's all it is. So what we need to do now is to connect these 2 points with a straight line. Then we have this connected to this. So this is what we have, guys. Having plotted the graph, what you now need to do is to what? Do what we call critical examination. Do critical examination here. So examine the graph critically to know what type of graph is this. What do I mean? Is this graph symmetrical about the origin or symmetrical about y-axis? These are the 2 conditions that we're given. So answer this question. Look at it. Just look at it. Please be happy. This course is not hard. Be happy. Yeah, smile. Can you smile more? Just smile. Smile. Oh yeah, let's go now. I think you are getting it right. So, what type of graph is this? Let me hear you. Oh, almost. You got it. This graph is an even function. Why? Because the graph we just plotted is symmetrical about y-axis. How? If I divide it y like this, what I have to the left is what I have to the right. And more also, these 2 lines that I have here are plotted at the positive section of y. It shows that the 2 values of y are positive. But when one value of y is positive and the other is negative, then it becomes odd function. Take for instance, when we solve this line gave us negative 4. Maybe that value will have been. So as long as the 2 values of y are positive, or all the values of y are positive, it shows that you already have an even function graph. Even without plotting this now, I'm giving you another mind-blowing code. Don't forget, when you understand principles, you become a principal. When you understand boundary conditions, you will not overstay your boundaries. Please and please, don't skip this video, because you may miss important parts that would have helped you know this course, this topic, this part for life. So now let's continue from where we started. Now, as we move now, we have found out that this graph is symmetrical about y-axis. Okay, let's put it here. Since the graph is symmetrical about y-axis, then it is an even function. You see it now? It is an even function. Now the question is, under the theorems of even function, we said that for even function, Bn is equal to 0. So if Bn is equal to 0, the next step after identifying the type of function is to state the equation between equation 1, 2, and 3. And it happens that this will be equation 2, because that is where Bn is equal to 0. So what you need to do now is to state equation 2. And in that equation 2, we did mention that f of t is given as 1 over 2 a naught plus sigma n equal to 1, 2, just like that, 3, 4, t infinitive, a n cos n omega t. So this will be our equation 1 here. So this is the equation we will use to solve this problem. So to be able to solve this problem now, for us to obtain the first 5 non-zero values, all we need to do is to get the value of a naught and a n. To find the value of a naught and a n, then we begin to substitute. From there, we'll get the first 5 non-zero values. Is this not simple? Very simple. So the next question that will come up in your mind is when you know these principles, you begin to know what next, because the problem most of you have is that when you are done with one step, you don't know the next step. But principles will help you know the step-by-step progression. Alright, the sequential order of solving the problem will be of value to you when you understand the principles. And that's exactly what this video is doing for you, this content. Okay, so this is the equation. So all I need to do now is to find A0, A0, and AN. So quickly, let's obtain the value of AN. A0 first. So now you then recall that A0 is equal to 2 over 3 integral of t over 2 minus t over 2 f of t dt. So these are my equation 2 now. So this is what we use to find A0. That means I need to find t over 2. Remember that t over 2 will be 8 over 2, and this will give us 4. So if I equally do 4 minus t over 2, this will give us minus 8 over 2, which is minus 4. We show that from this to this, and that is exactly what we have from negative 2, 4 to positive 4. That's what this graph is. So to solve this problem, there are two ways to solve for A0. So that means if I want to solve for A0 now, I will do for negative 4 to 0, get the value, then do from 0 to 4, get the values, then add the two values together. But that will be a very hectic way to solve this problem. The pathway to go through in solving this problem in that order will be so very, very complex. Not that it is not easy to solve, but it will take more of your time. So how do I summarize this problem? How? So since this graph is symmetrical about the y-axis, all I need to do now is to pick one of these functions. Either I go with the first or you go with the second, anyone you want to go with, and then use it limit, multiply this equation by 2. Because if you solve this and have 4, then you solve this, you also have 4 as your answer. If you solve with this and have 10, if you only solve with this other function, you also have 10. 10 plus 10 is 20. So it is the same way as solving for only the last one and saying 2 multiplied by 10. It will equally give you 20. I hope I'm not confusing you. If I am not confusing you, see how this model will now look like. So because this function is an even function and is symmetrical about y-axis, what I have to the left is what I will have to the right. So I will decide to solve with one of them and multiply the result by 2. So this equation becomes, since the graph is symmetrical, take f of t equal to 4 minus t, which is between 0 less than t less than 4. I decided to go with the second function because I needed my limit to be positive values. Okay, so I needed my limit to be positive values. You can go with this, then I'll be using this. So for this function now, this will be the limit. But for this function, this is the limit. So I'm using this limit. So because I want to use positive limit, I will go with this function. So because I am taking one function out of 2, I will use this one function to solve for both functions. So all I need to do now is to select. Therefore, A0 would have been equal to 2 times 2 over t integral of, this is now what, 2 times 2 over t integral of, we are using the limit, this function. So our f of t now will be replaced by this function t 4 minus t dt. Then I will now use the limit for this function 0 to 4. So these two that I just multiplied the model with now is covering for both functions. Covering for both functions. Covering for both functions. So all I need to do now is to put in the value. So this is A0 is equal to 4 over t. And remember, what is our period? Our period is given, remember, but period t is given as x. So anywhere you see t, you put 8 here. Then this will give us a naught is equal to 2. This will be 4. Is equal to 4 all over 8 integral of 4, 0, 4 minus t all dt. I hope you understand it to this level. Remember, what we need to do now is to integrate, and this is just one function in the bracket. So when we integrate by this will reduce to 2, 1 over 2. 4 into itself is 1, 4 into 8 is 2. Alright? Then we have, when we integrate a constant, remember you're going to integrate these terms individually. So when you integrate 4 being a constant, you now have 40. You remember this? And then when you integrate t, you have minus t squared over 2. All raised to the power of what? 4, 0. That's it. All we just need to do here now is to put in the upper limit as well, put in the lower limit, substitution. So while we substitute, we have 1 over 2 into, when we put in the value of t here, it becomes 4, that is 4 minus 4 squared over 2. I have just put in the upper limit. Anywhere you see t, put 4. That's what I've done now. Then minus 4 multiplied by 0. Then minus 0 squared over 2. This is it. All we need to do now is that it will give us 1 over 2 into 4 multiplied by 4 would have given us 16. This is 4 squared, which is same thing as 4 multiplied by 4, or 4 raised to the power of 2 is 16. And now 16 divided by 2 will give us negative minus 18. This is what we have for this. Then minus open bracket. 4 multiplied by 0 is 0. 0 squared divided by this is 0. That's it. So this is automatically 1 over 2 into 16 minus 8 will give us 8. And 0 minus 0 is 0. Everything here will give us 1 over 2 multiplied by 8, and this will be 4. Therefore, A naught is equal to 4. This is the value of A naught. Is this not simple, guys? Very simple. From here, we know that we are going to calculate for A naught and AN, and we have successfully calculated for A naught. Left with only AN. All we just need to do now is to solve the same way we have solved for A naught for AN. Once we get the values, substitute the values. A naught appears once, but AN continuously appears at different values. 1 when n is 1, when n is 2, when n is 3. But there is only one value for A naught. But on this node for AN, we have multiple values. In fact, infinite values for AN. But what we need to do now is let's find AN. After obtaining AN, then we can begin to substitute when n is 1, when n is 2. Remember, we have already used n is 0. This is when n is 0. That's when you have A naught. Okay, so to find A1, A2, A3, we need to first of all obtain what AN is all about. So, guys, this is what we have done so far. Okay? Okay, now, guys, we've wiped the board because of the fact that these problems actually will take a lot of space. So now, I hope you have put the record of what we had before somewhere. Okay, so you can put the values we have obtained so far somewhere along the line so that we can start looking for what next we're looking for. Okay, now let's look at this. So we will be looking at AN. Remember, we just obtained A naught. From our calculation now, A naught is equal to 4. But what is AN? Remember that AN is given as 2 over p integral of t over 2 to negative t over 2 f of t cos n omega t dt. This is equation 3. So now for us to be able to find AN, I need to put in the value of t. I need to find what is omega. Then we are integrating with respect to t, while n is constant with respect to this n. So I will not touch n, I will not touch t because I'm integrating with respect to t. But this capital letter t and this W, we need to know their values. Of course, we already know that T is equal to 8. And then this guy is giving us 2 pi T. And 2 pi T over 8 would have given us pi over 4. That means the value for angular velocity is pi over 4. So why we need, anytime it is required of us to put in the value of omega, we just put in pi over 4. We'll get there when we are fully substituting. Okay, and that's when we have already integrated the function. So what do we do now? We find out that here, this function we are still dealing with, if we want to solve this from negative half of t to this, it will still give us for the two graphs, right? Remember we had a graph like this. So for this line here, AB, then B to C. For AB, we'll calculate for it, then we'll calculate for BC and add them up together. But guys, that would be a very stressful journey for you to calculate for line AB differently, calculate from line BC differently before adding them up together. So the theory is that as long as this graph is multiplied by the y-axis, and then this function ranges within the same limit, whatever you have for AB is what you are going to have for BC. And as such, you can solve for just AB, multiply it by 2, or solve for just BC, and multiply it by 2. So remember, while we are calculating for A naught, right, we use BC, which was the second function. In this case again, we are going to use this function because any function you choose, use it all through. It will be easier that way and very simplified. Okay, straight to the point. So we used BC before where we had positive limits. So in this case now we are going to be taking one of those functions again, like we did for A naught. And while we are taking that, we'll be using the limit of only that one. And because of this reason, we'll be multiplying this by 2. Remember, we have already decided on that function, so I don't need to repeat it here for the sake of space. Okay? Now, if you understand what we are doing, let's jump into this and have it done. So what we need to do now is that we have AN is equal to 2 multiplied by 2 over t, integral of 4 minus t. This is the function we take or we choose earlier, and this is the limit. Cos n omega t dt. So what we need to do now is to put in the value of this guy. And if we do that, this will have given us 4 over 8 integral of 4 minus t cos n omega t dt. Now, guys, there is a need for you to pay maximum attention. A need, a call for maximum attention. But you may not pay much attention if you are good already with integration by parts. Yes, integration by parts. Now look at it. We have a linear function inside the bracket multiplying a trigonometrical function, cosine, right? So when a linear function multiplies a trig function, which remember these are two different functions, linear and trig. When you have the product of two different functions inside an integral, there is a call towards solve that problem using integration by parts. Now the question is, what is integration by parts? Integration by parts is actually integrating the product of two different functions. Integrating the product of two different functions. So for us to be able to integrate these two functions here, we need to what? Use integration by parts. That's all. So if you are good with integration by parts, there's no need to stress yourself. But if you are not, please, I need your maximum attention because I wouldn't want you to watch this video at the end. You are still having issues with this. No, I came prepared so that I will bless you once and for all. Okay, so let's go. Now, these are AN. Let me just extend it one more time. AN becomes 1 over 2 integral of 4 minus t cos n omega t dt. From here, I can say let AN be equal to, just follow me up, let AN be equal to 1 over 2i. This I will call equation 2. I think we have called equation 2 earlier. Okay, this will be our equation 3, equation 4 now. This is our equation 4. Based on this problem, we are solving question number 6. Okay? So we call this 1 over 2i. So what is represented by I now is this integral. So this full integral is what is representing by I. Then I have that I is equal to integral of 4 minus t cos n omega t dt. Now all you need to do is to recall that integral of u dv is given as uv minus integral of v du. This is the standard model or formula for integration by parts. While this one stands for the linear function, which is t minus 4, then the remaining part becomes your dv. So the solution to this integration by part is the right hand side. This one in the bracket. This is the solution. So comparing this left hand side to my I already know that my u will be this, my dv is this. But when I look at the final solution to solve this problem, I have u, I have v, I have v, I have du, but I don't have v yet. So all I need to do, if you compare this with this, take for instance, I call this equation A, then I call this equation B. If I compare equation A and equation B, only the left hand side. If I compare this with this, all I will have is that I'll simply say let u be equal to 4 minus t. So if I differentiate u here, du over dt. Remember that this is just a function of u and t. So I need to differentiate u with respect to t because u is the subject of formula. Why am I differentiating u? Knowing that this is u. Why am I differentiating u? I am differentiating u so that I can obtain du. Why do I need to obtain du? At the right hand side of this equation, to find my answer, du is required. This is why we are differentiating. I'm teaching you the concept of solving integration by part. I'm not supposed to have done this here. I'm not supposed to have done this here. You're supposed to have known at this level. You're supposed to have known integration by part, right? But let me just do it so you have to follow me. Then, this is my du, so I'm differentiating this now because I want to obtain du. And if I differentiate a constant, so if I differentiate a constant, I will have 0. And if I differentiate minus t, I have 1. So from here, what I need to do now is to make du the subject of formula because that's what I need. I don't need du over dt, I only need du. So how do I make du the subject of formula? To make du the subject of formula, just simply cross multiply. And then du is equal to dt multiplied by 1 will become minus 1 dt. But I just need only minus dt because that one as a coefficient does not really count. So I can call this equation C. Okay, then let's move to the next part. The next part is that whatever that remains here, the remaining portion here becomes this dv. So we have that dv is equal to cos n omega t dt. So now from here, I know my dv. But in the solution that I need at the right hand side of this model, there is no dv, only v. So how do I get my v from dv? You need to integrate this portion. So from here, you just introduce your integral. If you integrate dv, you have v. And if you integrate this guy here, let me just introduce integration sign so that you won't have issues with it. So when you integrate cos n omega t, remember that if you integrate cos 3x ds with respect to x, your answer will give you what? Sine 3x all over. Differentiate this 3x. What do you have? You're going to have 3. Since we are integrating with respect to s, you will differentiate the angle in front of the cosine term. Now, like this one we are solving, we have cos n omega t. So that shows that nw is the coefficient of t. So if we differentiate this nwt now, what will be left is wt. So what will be left is what? Nw. That means if I integrate this, I will have sine n omega t all over n omega. It shows that anytime you integrate cos angle x, whatever value it is, it will always be that value at the denominator. Are you there? So the value is what you have at the denominator. So the coefficient of t here is what we take to the denominator. The same way, the coefficient of x here is what we brought down to the denominator. Don't forget that when you integrate cos, you have positive sign. It's only when you differentiate cos that you have negative sign. Don't forget this. Okay? So this is what we have. Anywhere we see V now, we'll be positioning, substituting sine n omega t over n omega. Are you there? So this is the resulting integral of cos n omega t. All we just need to do now, if this is, we agree with what we have here, is to substitute equation C and equation D, or okay, into equation what? B. All we just need to do now is to substitute everything that we have here into equation B. Knowing fully well that this is our I, so we then have I is equal to U V minus integral of U V du. This is what we have. Now, know very well that this is equivalent to what is our U? 4 minus T. And what is our V? V is sine n omega t over n omega. Then minus our integral. We introduce the integral. What is V again? Sine n omega t over n omega. Remember that du is negative dt. So now put in negative dt. So we now need to simplify this. In simplifying this, we'll have that I just put this model here to show that this is what we are substituting into. I did mention earlier that what I cycle here is the general solution. So this is what we need to substitute into. We don't need this part. We don't need this part again. The only part we need here now is the upper and the lower limit. Okay? So this will have given us 4 minus t sine n omega t all over n omega. Then minus times minus, we turn this to plus. And remember that this is a constant. It can come out to have 1 over this integral of sine n omega t dt. This is what we have. So when we now look at this integral now, it's now an integral of one function, only 3. That means we can just integrate and get our final result. We are not going to implement the law of integration by part here because this is no longer a product of 2 functions but just a singular function. So the same way we did this, we treated this guy, is the same way we are going to treat this guy now. So all we need to do now is to have that this is equal to 4 minus t sine n omega t all over n omega. Then plus 1 over n omega. If we integrate sine, we'll have negative cos n omega t all over n omega. Don't forget it will always come out. Now in this wise, we can now put in our limit after successfully integrating the whole function. This is what we have. So when we simplify this function, guys, our result, remember we are calculating for r, would have become 4 minus t sine n omega t over n omega minus plus times minus will give us negative cos n omega t all over n omega. Now when we multiply the denominator, n multiply n, we have n squared, and w multiply w, which is omega, we have omega squared. All into 4, 0. All we just need to do here now, guys, is to apply both the upper limit. We have successfully integrated the function. So all we need to do is to put in the upper limit and put in the lower limit, and as well put in, recall that w is equal to pi over 4. The result is still here. So we will be substituting for angular velocity inside or in front of the trig, and then we will be substituting for t. So the first value of t now is the upper limit, which is 4. So anywhere you see t here, put 4, and anywhere you see omega t in front of sine or cosine, put pi over 4. But if it is not there, like we have a denominator, we will not substitute for the ones at the denominator. Okay? So we then have that I is equal to. Please, we are quickly going to use shortcut here so that we will be able to maximize this place. Look at what will happen here. Okay, I can rule here now. Look at what will happen here. If you put in 4 here, this will be 4 minus 4. Remember, we are substituting 4 first. So we are putting 4 here now. If I put in 4 here, this will be 4 minus 4. 4 minus 4 is 0. So automatically everything here becomes 0 times 0. Then multiply by sine n. What is omega? Pi over 4. Multiply by what is t? 4. All over n omega. Then minus. When we put t here again, now we'll have this as cos n pi over 4 multiplied by t is 4. Okay, so now we have successfully substituted in the upper limit, and now we're going to substitute in the lower limit. So to put in the lower limit, anywhere you see t, you put in 0. So this will now be what? 4 minus 0, and then this will give us 4. Remember, 4 minus 0 is 4. Then multiply by sine. Remember, if I put in 0 here, anything multiplied by 0, we are supposed to have pi over 4 and pi over 4 multiplied by 0. All over n omega, then minus. When we now put the value of t here, again, this will give us cos n pi over 4 multiplied by 0 all over n squared w squared. So now guys, we have successfully substituted both the upper limit and the lower limit. Now let's quickly break down this. What we need to have here now is that if we multiply this by 2, 4 cancel 4, in fact, everything here will be 0 because anything multiplied by 0 is 0. So we don't even need to stress ourselves here. We have 0 over n omega. Okay, this is what we have here. Anything multiplied by 0 will be 0, irrespective of what you have here. Then for this, 4 multiplied by 4, 4 cancel 4, we will have this as minus cos n pi. This is what is left here. 4 will cancel 4. N squared omega squared. Then minus this 4. Now, if you multiply pi over 4 by 0, anything multiplied by 0, guys, is 0. Right? So it's 0. And then n multiplied by 0 is 0. So this gives us 4 multiplied by sine 0 degrees all over n omega. Then minus. Everything here also would have given us what? Cos 0. Anything multiplied by 0 is 0. So 0 multiplied by n, we have 0 degrees over n squared omega squared. This is what we have. Now the next thing is that everything here will be 0 and everything here will be 0. This is automatically 0 and this will only be 0 because 4 sine 0 is 0. Don't forget, sine 0 degrees is 0. So 0 times 4 is 0. That makes everything here to be 0. So our I has been reduced to what is left here now is minus cos n pi over n squared this squared. This is equal to 0. So what is left here now is that cos 0 degrees is equal to 1. So that means the numerator here will be 1. Now remember there is minus here. Minus multiplied by minus would have turned this to what? Positive 1 over n squared w squared. Finally, guys, our I is now equal to, now if we decide to rearrange this, we will have this as and factorize. What is common at the denominator is 1 all over n squared w squared. If I open bracket, the coefficient of the, remember I just put out the denominator. So what is left at the numerator here now is 1, and what is equally left at the numerator here is minus cos n pi. This is our model. This is our model. So guys, we have successfully obtained the model for this equation. So generally, for us to have found the value of an, remember we'll come back to equation 4. In our equation 4, recall that in equation 4, an is given as 1 over 2, which is equal to 1 over 2 into what is I? We just said now that I is equal to 1 over n squared w squared into 1 minus cos n pi. Alright? So if we further this, an becomes 1 over 2 n squared omega squared 1 minus cos n pi. This is the model. So this is now the equation for our an or a subscript n. This is now the equation. All we need to do, having gotten to this level now, is when n is 1, put n1 here, put anywhere you see n, put 1, you get the results. A whole number in terms of angular velocity. Anywhere you see n, put 2. Anywhere you see n, put 3. Anywhere you see n, put 4. Anywhere you see n, put 5. Just like that until you obtain the first 5 non-zero values. Remember, we have obtained the first value, which is our an1. That means we need 4 more to add to this to complete it, the first 5 non-zero. So that means in this case now, a subscript n or an will be looking for 0 values in that we will add to this guy to make it the first 5 non-zero values. Guys, you find out that this is not actually hard. It's a bit complex here because we apply the law of integration by parts. So if you do not know integration by parts, there is a need for you to go and study integration by parts so that when you start solving problems on this, you will solve it with ease. The next thing we are going to do now is to quickly run the analysis of when n is 1, put in the value, when n is 2, put in the values, when n is 3, put in the values, when n is 4, put in the values, just like that till we get our solution. Again, we are quickly going to clean up this whole mess we have on the board. We are going to clean everything again so that we'll start from this column down to this end. And then after covering this page to this page, we will be able to get the final result. So guys, let's quickly rub the board as we progress from A1, A2, A3. Okay guys, now we already have A0. And remember, the last equation we have is that AN is equal to 1 over 2 n squared omega squared all 1 cos n pi. So now the question is, remember that n ranges from 1, 2, 3, 4, 5 to infinity. Infinite sum of cosine and sine term we define as Fourier series. Okay, so now when n is 1, we have a1 is equal to 1 all over 1 squared w squared into 1 minus cos. Now remember that pi has 2 values, one for geometry, then the other for trigonometry. For geometry, pi is equal to 22 over 7. But for trigonometry, pi is equal to 180 degrees. And like we are dealing with now, we are dealing with trigonometry. So anywhere we see pi, we will be substituting 180 degrees. Are you with me? So that's what we'll put here. So that this will have given us 1 multiplied by 180. And this will give us 180 degrees. Please, don't put in pi here 1 times pi, you have 1 pi, and put this in your calculator. When you substitute this in your calculator, it's going to solve it using the value for geometry. Okay, so anytime you are dealing with geometry, you make use of this, but when you are looking at tree, use this. And while you are using this, put in the value yourself as 180, otherwise it will record this of 3.142 approximate value of 22/7. Okay, if this is correct, then A1 would have given us 1/2 W squared. Remember that 1 square is 1. So we have this at the denominator into 1. Now remember again, all you need to do here to summarize this sum is just type in 1 minus cos 180 in your calculator and the answer will be 2. How? Cos 180 is minus 1. Cos 180 degrees is minus 1. So when you put in minus 1 here, minus times minus 1 will give you plus 1. So automatically everything here will give you 2. So we just put in 2 here. These 2 cancel these 2. We'll have this as 1/W squared. We have gotten the second non-zero value. Left with 3 more. Then again, when n is 2, we have 1/2 into 2 squared W squared. Then we have 1 minus cos. Now remember, this will now be 2 multiplied by 180. Pi is 180, n is now 2. And that will give us 360 degrees. Now, this will give us 1/. If you square 2, it will give you 4. 4 times 2 is 8. So this will give us 8W squared into 1 minus cos 360 will give you 0. Why? Cos 316 is 1. 1 minus 1 is 0. So this makes the result for this as 0. So you see now that we have a 0 value. And don't forget, we are looking for the first 5 non-zero values. Then we have A3 is equal to 1/2 into 3 squared W squared into 1 minus cos. 3 multiplied by 180 would have given us 540 degrees. Are you there? 540 degrees. 540 degrees. Now the cos of 540 is minus 1. Or better still, just type in your calculator 1 minus cos 540. You will have 2. Then A3 will give us 1/18. Remember, if you square 3, you have 9. 9 multiplied by 2 will give you 18 W squared into 2. And now 2 into 18 will give us 1/9 W squared. This is what we have. Now let's progress here. Again, we have A4. When n is 4, 1/2 into 4 squared W squared into 1 minus cos. Now remember, if we come here, n is now 4. 4 times 180 will give us 720. So put down 720 degrees here. And then this will have given us 1/32 W squared into 0. How? 4 raised to the power of 2 is 16. And 16 times 2 is 32. Why we put down this? The cos of 720 is positive 1. 1 minus 1 is 0. Or better still, just type into your calculator 1 minus cos 720. And this is what you have. Automatically, this will give us 0. Nice. So if this gives us 0, that shows that from what we have done so far from A1 to A4, A1 is an odd number, A3 is an odd number, yet we have values for them. But for A2 and A4, their values are 0. It shows that if we keep substituting into this equation, for every odd numbers, we will have values. But for every even numbers, we will always have 0. But eventually, if I solve for 6, I will have 0. If I solve for 8, I will have 0. 9, I will not have 0. But if I solve for 10, I will have 0. Just like that. So for every even values you put here, you always have 0. So what do we need to do? I don't need to start calculating for all that. All I just need to do now is to deduce a model. That's all. So what I just say now is that similarly, A5 will be the next, will be 1 over 25 W squared. Look at it. For 1, this is what we have. If you square 1, this is what we have. When you put 1 square here. Now, for 3, we have 9. So that means for 5, we will have 25 here. For 7, okay, let's say 6. For 6, we will have 0. For 7, we will have 1 over 7 squared, will give us 49. W squared. And then for 8, we have 0. That's it. So it shows that an is equal to 1 over n squared W squared for odd values, while an is equal to 0 for even numbers of values. This is what it means. That's all. We are done with this. So now we have gotten 1, 2, 3, 4, and 5. We stop here. But if I want to find 9, I will now have to put n here. 9 squared would have given us 81. Because 1 over 81 W squared. That's it. So if this is gotten, all we just need to do now is to recall our equation 1. We stated earlier that f of t is giving us 1 over 2 a naught plus summation to infinity. Summation to infinity from n equal to 1 to just like that. Then we have an cos n omega t. All we just need to do now is f of t is equal to 1 over 2. We begin to substitute in their values. A naught has been calculated to be 4. Put in the values plus. Remember that this summation, so we go with 1. Put 1 here all through this equation. This will give us a1 cos 1 omega t n1. So plus a2. But because a2 is 0, a4 is 0, a5 is 0, I will just go with the one that has values. So I will jump to a3 cos n is now 3 omega t plus a5 cos n is 5 omega t plus a7, I will jump a6, be an even number again. Then I have cos 7 omega t. This is what we have. So anyway, I see here when I put in the value just like that. So this would have given us, this cancel this, we have the first value to be 2. What is a1? 1 over omega squared cos omega t plus 1 over 9 squared cos 3t. Omega t. Then plus 1 over 25 cos 5 omega t plus, this is infinity, 1 over 49 W squared cos 7 omega t plus the infinity continues. Then this is our answer. You can decide to factorize. Like what is common between from here downward, we find out that 1 over W squared is common, so we can factorize and then have finally that f of t is equal to 2 plus 1 over omega this, open bracket. So pick this plus 1 over 9 cos 3 omega t plus 1 over 25 cos 5 omega t plus 1 over 49 cos 7 omega t, then plus that, just like that. So this is the first question we are asked to solve, which serve as A. Question number A. So very quickly, we're going to run down through the analysis of question number B here, and then we'll just rush it and get the final result. Otherwise, we'll have cleaned up this part again, but I don't want us to clean up this part. Okay? Alright? This is how it is. So how do we now find the percentage nth harmonic? Remember, we are asked to find the percentage third harmonic. Okay? So B, percentage third harmonic. Remember, the equation is Bn over B1, right? So percentage third harmonic becomes B3 over B1 times 100%. This is the formula to find the percentage third harmonic. So our B1 is the first value for A1. We'll solve that out now very quickly. So how do I get B1? B1 is equal to the square root of A1 squared plus B1 squared. Remember, because this function is an even function, B, small letter b, is 0. So all we need to do now is that what is our A1? Our A1 was 1 over W squared, all squared plus 0 squared. And when we find out the value of this, the resulting value becomes 1 all over W squared. Having obtained these guys, the next thing we are going to obtain is to obtain B3. And in obtaining B3, we understand that the equation will also go this way. 3 equal to the square root of A3 squared plus B3 squared is equal to. Understand again that B3 is equal to 0, which is subscript. B small letter b is also equal to 0. But I have A3. And our A3 is 1 all over 9 omega squared all squared. Then plus 0 squared. And the answer to this is 1 over 9 W squared. That's all. So we have obtained B1, we have obtained B3. All we need to do now is to put in our values into this equation, and we will be able to obtain our result maximum. So we have percentage third harmonic is equal to, what's our B3? Our B3 is 1 over 9 angular square. Now divided by, so in this case, if you believe that A over B is the same thing as A divided by B this way, then I'm going to use this division so that I can maximize this page here. Okay, so I'll use this division. 1 over W squared. Then all multiplied by 100 degrees. Alright, so this is what we have. All we just need to do now is to have this as 1 over 9 omega squared multiplied by W squared over 1. Remember, we use the law of inversion. When you change division to multiplication, you invert the fraction. Numerator becomes denominator, and denominator becomes numerator. Are you there? Then all multiplied by 100 degrees. So this takes care of this, and we'll have this as 100% over 9. 100 divided by 9 will give us 11.111111. So we have 11%. So this is the answer to part B of this question. So guys, we have been able to run through this question from beginning to the end without skipping any part. If there is any part in this content that you do not understand, please, all you need to do is to replay the video over and over and over and over again until it sinks into your mental capacity. There is every high possibility that you can understand this topic from this channel and from this particular video. All you need to do is to replay the video. Then if you have any question, guys, type to the comment section and make your questions known to us. Guys, if you have been so engaged with this content till this level, in other words, you watch this video from beginning to this level, and then you have not subscribed to this channel, please consider subscribing to our channel. This is the only way you will motivate us to do more. Of course, if you are being on this page, watching this video to this time, it shows that it is adding massive values, not just values, to your life. So subscribe to this channel, like this video, make your comment known to us at the comment section. So even though you do not have question, please give us a positive comment and don't forget to share this video in your social media handles so that other students across the nation and across the world will have access to this mind-blowing content released by the wise masters. Very shortly, guys, we'll be looking at the next example, which is question number 2. And I know that that session is going to blow up your mind the more. What we are going to quickly do in that session is to look out for what an odd function. We're going to be solving problem on an odd function. Thank you very much. See you in question number 7. Wow, hello guys, welcome back to another section. In this module, I'll be solving exactly question number 7 in our Fourier series journey. I know you have been enjoying this class, and as such, I'm also ready again to give you the very best as we solve this problem. Guys, even though you cannot see the board very well, just see how you can pay attention to my words. I believe that they are capable of impacting your life if you can engage yourself massively without distraction. Okay, so guys, again, we have another problem before us, which happens to be question number 7. Don't forget that this is a continuation class, and as such, we have this as question number 7. Now we are asked to determine the first 5 non-zero terms of the Fourier series for a periodic function defined by f of t, 3 minus 3, at what range? -2 to 3 to 0. And then we have f of t, t plus 3. From what range? 0 to 3, then to 2. Then we have f of t equal to f of t plus 4. And I did mention earlier that this 4 you have here is the period of the function. And if you want to ascertain the period very, very well, or you want to be sure of the period, or maybe you are not given, you want to get the period, just add this value, the first value to the last value without considering their negative sign. So take this as positive. 2 plus 2 will give us 4. That is the period. This is the range to which the periodic function is defined. But only the first function is defined as half-range series. Only the second function is also a half-range series. But the combination of the two functions has given us what? A complete periodic function. So when you are dealing with a periodic function that is not complete, okay, we call it half-range series. Okay, so only this is half-range series, only this other guy is half-range series. Similarly to question number 6 that we saw, the first function is half-range series, the second function is equally a half-range series. But the combination of both is a complete periodic function. So guys, what do we do here? If this is a problem that we are to solve, not a problem much to threaten you or to get you scared or to make you to be afraid, not such. This problem is very simple, and it will only be simple to those who have known the secrets. So if you have not watched the principles to solving this problem, please replay this video from the beginning so that you will get yourself balanced up with the principles and the boundary conditions that will help you gain mastery in this course. As usual, when you understand principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. So guys, without further ado, let's jump into solving this question. Again, let me hold your hand again as I join you on the step-by-step processes of solving this question. Now, the first thing that you always do when you have a problem like this is to check whether you are dealing with an odd function or you are dealing with an even function. It is very, very important because this is what we determine the equation you're going to make use of among the first three equations that I gave earlier to solve for any Fourier series for any given periodic function. Are you there? So there are three equations. So the first, second, and third. So I need to know whether I am to use the equation 1, whether I'm to use equation 2, or whether I'm to use equation 3. This is very, very important because I always tell you guys the best way to solve a problem is to define the future from the beginning. Begin to see the promised land so that journey through the wilderness will not become a problem. Because if you can see the promised land, you can bear the burden and the distractions that you will experience while you go through the wilderness. Are you there? So, how do we get this problem solved? We said that the first thing we do to be able to ascertain whether it's odd or even now is to have a rough sketch, a graphical representation of this given periodic function. How do we have this done? And I did mention that the first function was given from a line. The second function is also given from a line. So now, how do I get the line that gave these results? Then, I referred you in lesson 6 or question 6 to go and watch question 1, question 2, question 3, question 4, and question 5 in lesson 1, part 1 of this lesson. Okay? So that you will get the full knowledge of how this is done. So how do we get this done? I will take the first function, f of t is equal to t minus 3, defined within the range of -2 less than 3 less than 0. And I did mention that this is t1 and then this is t2. So we have two values for t, and equally we are going to have two values for f of t. And we mentioned earlier that this t represents x-axis, which means we can tell this as x1, x2, while f of t represents y-axis, which means we can have this as y1 and y2. Understood? Now, if this is taken, so what we need to do is when t is 1, for t1, when I have the value as -2, I will put it into this equation to get a result for f of t. And when t is not equal to 0, I will equally put the 0 in place of t here to get a value for f of t. So we have that f of t f of t is equal to, so the first value is -2 minus 2 minus 3, and this will give us -5. Now the second is that f of t is equal to, the next value is now 0. So 0 minus 3 is equal to -3. We have gotten the first two values to plot the first line. Now we want to use the second function again, the second half range series, to find the second graph. Then we have f of t given as t plus 3, defined within range this to this. So this is t1 and this is t2. So we are actually going to have f of t1 and f of t2, two values. So when t is 0, we have f of t to be 0 plus 3, and this will give us +3. And then when the value is now 2, we have f of t is equal to 2 plus 3, and this will give us 5. So guys, we have been able to obtain the values that will help us to plot the graph. While we were looking at question number 6, can you remember one of the principles I added to the one I gave before? I gave you one principle before we started looking at question 6. And while we were looking at question 6, I gave you another principle to identify even function. Remember that was even function. Here now we don't know whether this will be odd or even. But one of the principles I gave is that all the values of will either be positive, for it to be termed as even functions, or some will be positive, some will be negative, for it to be termed as odd. So when we check the value of f of t, now which are the values of y, the first two values we have are negative, the last two values are positive. This graph is going to come out as what? An odd function graph, which is a graph that is symmetrical about the origin. Another key. So how do I know from here, even without plotting the graph, I haven't calculated for this value now? As long as these are negative, these are positive, they are equal and opposite. This makes it odd function. Odd function, equal and opposite. But even function, same pattern. Either plus plus or minus minus or true. That's it. That's how it works. Are we on the same page? If we are, then I have blown up your mind again. Follow me, let me give you another key. Now, what we are going to do now is to plot the graph, and then we have a rough sketch. Alright, so this is the origin, the point of intersection between x-axis and y-axis. Y here become f of t, and this guy here will become rt. Are you there? That's it. So now the next thing is, I will need to check out for the values of t. The values of t is between -2 to +2. So if this is my origin, I can just say that this is 2 or 1, 2. 1, 2. Or let me not rough this, let me just make it very straight. Then this will give us -2. Measure the same interval here. This gives us +2. I've gotten that for x. Then for y, I have -3, +5. Remember, you can use the same scale for x and y, you can use different scale, but in this case, I'm going to use different scale so that I can be able to maximize my paging. Okay, so how do I have this done? I can decide this, okay, 1, 2, 3. Somewhere here is my 3, as I label now. Y somewhere here is my 5. The same way, somewhere here is my -3, then somewhere here is my -5. Alright? That's all. Haven't been able to position these values. The next thing is to plot. So when the first value of t is -2, we had -5 for y. So s -2, the other -5. So you trace the point of intersection where the two lines meet is where you mark out. That's the point. Then again, when the other was now +0, when this guy is now 0, which is still was now 0, this other guy gave us -3. This is what we have. That's all. So what we need to do now, we are done with this function. So we can now connect this line. Let me take this guy up. So this is where I have my -2. So you join this, and then you join this. You can now decide to shade if you want to. This is it. That's like this. Remember, vertical lines don't count. We only use it to have a closed loop. This is the linear line that we have. Now, we want to get for the second function. For the second function, when we were still at the origin for t, or when t is 0, this guy is +3. So 0, +3. Okay? Now, when this guy is now 2, here, the other guy is 5. So you trace the point of intersection, maybe it's somewhere here. Then you mark. All you need to do, join these two lines. Okay? Join the lines, then bring it down to 2. That's all. So you can equally shade this. So when you check now, if I am at the origin, what I have is symmetrical. But when I'm at y, it's not symmetrical about y-axis. It's symmetrical about this. And how do you get to know this? Like I did mention earlier, when one part of the graph is at the negative section of y, and the other is at the positive section of y, you have a graph of what? An odd function. function. But for even, both will either be on top or both will be beneath. I hope this have actually given you a full understanding as how you can differentiate between even function and odd function, studying the theorems of even function and odd function. I think that they deserve a hand of applause. After this class, ensure you give me a call so you can take me out and give me a very cheap bottle of Heineken to cool my body, cool my state of mind, right? Now, so from what we have now, this graph is a graph of and what? Odd function. So since the graph is symmetrical about the origin, it is an odd function. So you now recall, for every odd function, applying the theories of even and odd function now we are applying the theory of odd function. For every odd function, a naught is equal to 0, and then an is equal to 0, but bn is not equal to 0. So automatically, we already know the value of a naught, we know the value of an, and this question says that we should look for what? The first 5 non-zero values. That means the a naught will not count, an will not count. It's only the bn that we count, but we do not know the value. So the question is, how do I calculate for bn? And also, what is now my general equation for this Fourier series? The general equation for this would have become f of t is equal to summation to infinity, n equal to 1, 2, just like that. Then we have bn sine n omega t. So we'll call this equation 1. This is our general equation for this function. It's as simple as this. Very simple as this. All we just need to do from here now, this particular spot where we are, is to what? Find a way to obtain b. Then we recall that to find b, bn is given as 2 over p integral p of 2 t of this f of t sine n omega dt. This is our equation 2, guys. So to solve for this now, we now need to apply the law of symmetry. Since we know that if we solve for this, we'll have 8, for instance, then we solve for this, we also have 8, that the result is as good as saying 2 times 1 of the function, because the sum of 8 plus another 8 will give us 16. And on the same ground, 8 times 2 is 16. Understood? So if this is clear, I'm just using an example, okay? If this is true, that whatever we will have for this is what we will have for this. Instead of calculating for this using f of t as negative t minus 3 here, solve, get the answer, then take f of t as t plus 3 and also solve for this there at the end, add the two results. That will be a very complex journey. All we need to do is to pick one of them and then multiply by 2. Me, I like simple life. I don't like using negative as limits, positive. So since I have a choice of choosing a positive, I will go with the positive. So because of this limit that I'll be taking now, I will take this function. All I need to do now for symmetry, because it is symmetrical, I will now have that take f of t as t plus 3 for which limit now? For 0 less than t less than 2. All I need to do now is that my bn automatically would have become 2 multiplied by t by 2 over t integral of, I will now be using the limit of this function. 2, 0, t plus 3 sine n omega t dt. Now remember where t is given as what? 4 units, such that angular, remember this angular will substitute for this angular, so we need to find t. This t already given. Angular is given as what? Pi, 2 pi over t, which is 2 pi over 4, and this will give us pi over 2. Understood? That's it. So having gotten to this level, all we need to now is to put in the values that we need to substitute here. And then we have dn is equal to, this will have given us 4 over 4. Remember the value of t is 4. 2 times 2 gives us this numerator as 4. Then the value of t is 4. We now have integral of 0 t plus 3 sine n omega t dt. So I have that my dn is equal to 4 divided by 4 is 1. So we have integral of 0 t plus 3 sine n omega t dt. So let's assume we call this equation 3 now. So from equation 3 where we are, all we need to do here now is to integrate this function. But looking closely into this integral, we will find out that we have the product of 2 functions. This is linear function in bracket multiplying a 3 function. And then we have that anytime you have an integral that contains the product of 2 different functions or 2 distinct functions, what you need to do is to apply integration by parts. So to apply the integration by part, we now need to state the integration by part theorem. It's as simple as this. Am I blowing up your mind, guys? Are you beginning to gain massive values already? If that is true, that you are gaining massive values, let's continue. Very quickly, we'll wipe this page so that we'll continue our solvings from here. Okay, now we move. We'll now recall that using integration by part, integral of u dv is equal to uv minus integral of v du. Like I did explain in the first module, in the first example we solved under this, that this part is the part required. This is what we need. So our BA now is actually equivalent to this. This polynomial, the polynomial function you have there, or the same thing as linear function, is u, while the remaining part becomes the v. So if this is the part that we need, that means I already have my u, but I don't have v. Now let's extract the parameters. Where u is equal to t plus 3. And now when you differentiate u with respect to t, because this is a function of u and t, this would have given us 1. If you differentiate t, you have 1, but when you differentiate 3, being a constant, you have 0. Then, remember we are not looking for du over dt. In this equation, what we are interested in is what? Having du. So that means I need to make du the sort of formula here by cross multiplying both sides, right? So if I do cross multiply here, du would have given me 1 multiplied by dt will give us dt. So that means anywhere I have du, I will put dt. Then I rule this end. At this point, guys, I have that the remaining part dv is equal to sine n omega t dt. Now that I have dv, or at the right hand side, which is actually the solution to the integration by part, I do not have dv there. I only have v. So how do I obtain v from dv? You need to integrate dv so that you can have v. How do we do this? All we just need to do now is to introduce integral dv is equal to integral of sine n omega t dt. Now when you integrate dv, you have v. If you integrate this, understand that when you integrate sine, you have negative cos. This is the angle n omega t all over. What is the coefficient of t? Remember we are integrating with this. So everything in this cycle, it becomes our denominator. And I did explain earlier that if you have integral of sine 5x dx, if you integrate this, This will give you minus cos 5x all over 5. The coefficient of x is what constant. So if we believe that this theorem is valid, therefore it's applicable here. That's it. All we just need to do now is that we'll come to this equation anywhere we see v. So let's assume we call this equation 4 now. Anywhere we see v, we put the result. Anywhere we see u, we put the result. Anywhere we see du, we put the result. Just like that. Is that clear? So now we just record that Bn is equal to uv minus integral of v du. So we have, what is u? T plus 3. And what is v? We have minus cos n omega t over n omega. Alright? Then minus integral of this integral. This negative sign is this. What is v again? Negative cos n omega t over n omega dot. What is du? We said du is dt. Remember that the limits are still there, okay? Which is the lower limit and the upper limit. As we progress from here, if we multiply this, this will give us negative into t plus 3 cos n omega t all over n omega. Minus times minus, we turn this to plus, then we bring out the coefficient, which is 1 over n omega. Integral of what? Cos n omega t dt. Now, when we look closely to this integral, we find out that we only have 3 functions. This is no longer a product of 2 functions, but just 1 function. So we can just integrate this finally and get our results. So when we do the final integration, we will have this as negative t plus 3 cos n omega t over n omega, then plus 1 over n omega. When we integrate cos, we have positive sign. So we now have sine n omega t over n omega. Then we can now put down our limits, which is 2 to 0. Now that we have successfully integrated the whole function, we put in our limits. So if we extend this now, open the bracket, we'll have that our Bn is minus t plus 3 cos n omega t over n omega, then plus sine n omega t over n multiplied by n. If we open the bracket, we have n squared, omega multiplied by omega, we have omega squared. Then all into 2, 0. This is now our Bn. Remember, what we need to do now before we start substituting for when n is 1, when n is 2, is that we have to apply the upper limit and lower limit very, very quickly. We need to apply this. So let's clean the next page of the board so that we can start solving our problems over there. Are we there? I hope this is clear enough. Okay, now that if it is clear enough, so now we want to put in our upper limit and lower limit. We then have Bn is equal to, so the upper limit is 2. If I put 2 here, remember, if I substitute 2 here in place of t, remember at this point now, we are substituting for both t and angular velocity. Remember, we did mention earlier that angular velocity is equal to pi over 2. Don't forget, this is what we have when we calculated for angular velocity, right? This is what we have. So anywhere we see t, we will put 2. Anywhere we see w in front of trig, we will put this pi over 2. Except for the one we have at the denominator. We don't substitute for the angular velocities over there. Are we there? So we have Bn is equal to. So when we put 2 here, 2 plus 3 will give us 5. So we then have this as minus 5 cos n minus 5 cos n into, what is omega? Omega is pi over 2 and t is 2 all over n omega, then plus, again we substitute for this, we have sine n into pi over 2 multiplied by 2 all over n squared omega squared. Then we have this. We have just succeeded in substituting the upper limit. Very quickly, we want to substitute the lower limit, which is 0. So anywhere we see t, we put 0, and anywhere we see angular velocity in front of trig, either sine or cosine, we put in pi over 2, like we have done in the first part. So if we put 0 here, it becomes 0 plus 3, and this will give us negative 3 cos n into pi over 2 times 0 all over n omega, then plus. Again, the next one here is sine n omega d. So we have sine n into pi over 2 times 0 all over n squared omega squared. So we have this. So we have succeeded in putting the values of the limits. All we need to do now is to simplify this one. Then we have Bn is equal to negative 5, 2 into 2 will give us cos n pi all over n omega squared. Alright, then plus 2 into 2 would have given us sine n pi all over n squared w squared. Then minus into minus. For this other guy, we have minus 3 cos 0 all over this plus sine 0, anything multiplied by 0 is 0 all over n squared omega squared. This is what we have. Now, all we need to do now is, remember, cos 0 is 1. Now, sine 0 is also 0, right? Cos 0 is 1, sine 0 is 0. We applied this in the first problem. We put the values there. Understand now that the sine of pi is equal to 0. Please, I want to teach you a theory here. The sine of pi is equal to 0, which means sine 180 degrees is equal to 0. So even though you multiply 180 by 1, by 2, by 3, by 4, by 5, by 6, it will continuously give you 0 as long as there is 180 inside the value. What I mean is that if I have sine 2 multiplied by 180, it will give me 0. If I have sine 3 multiplied by 180 degrees, it will also give me 0. Guys, you have your calculator with you. Verify this yourself. So that you hold on to this theory. Not just that you heard it from the wise master, but as well, you have confirmed this yourself. So the sine of 180 is 0. And the sine of 180 multiplied by any number will equally give you 0. What I'm trying to say in this segment is that everything here will be 0 because sine n pi is 0. Any value of n at all multiplied by pi will always give you 0. And remember that in this case, pi is equal to 180 degrees, trigonometry, not geometry. Are you there? Now, again, sine 0 is 0. Automatically, this whole expression will equally give us 0. So I'm left with this and I'm left with this. So by simplifying this further, we'll have that Bn is equal to negative 5 cos n omega all over n w. Now what is left here now? Minus times minus, we turn this to plus 3. Remember that cos 0 is 1. Sine 0 degree is 0. cos 0 degrees is 1. So 0 divided by anything is 0. That's why this ratio is 0. The same way here, this is 0. 0 divided by anything is 0. So we just ignore it in one step. We don't need to start wasting our time looking at what we know they're already 0 by trying to simplify them further. There's no need for that. Okay? Now, then the cos of 0 is 1. So 3 times 1 will give us 3. Minus times minus turn this to positive 3. All over n omega. All we need to do now, the denominator is common. We then have that Bn is equal to 3 minus, okay, what is common is the denominator, which is 1 all over n w into 3 minus 5 cos n pi. This become equation 5, I think so. That will become our equation 5. Yeah, this is equation 4. This is equation 5. So now that we have successfully substituted the value of t and omega, and then we have arrived here, this is the model or the equation for Bn. All we just need to do now to be able to get our general solution is that anywhere we see n, we put 1, we put 2, we put 3, till we'll get the first 5 non-zero. Remember, at this point, we have not gotten anyone. Unlike even number, when we saw for a naught, we had a value. But this case now, we have not gotten 1 out of 5. So we now need to start looking at this very, very proper. Okay? All we need to do now is, let's quickly rule here. Remember, recall that n ranges from 1, 2, 3, 4, 5, and so on. So when n is 1, b1 is equal to 1 over 1 w into 3 minus 5 cos. Now remember again that pi, that as we are using here, pi is equal to 180 degrees. So 1 times 180 will give us 180 degrees. And if you put everything here into your calculator, put everything here inside your calculator, you're going to have a very good result. And the result here would have given us 8. Just take your calculator, type in 3 minus 5 cos 180. You will have 8. Otherwise, cos 180 is negative 1. Minus 1 times minus 5 will give us 3 plus 5. And 3 plus 5 will give us 8. Okay? So this will give us 1 over w into 3 plus 5. Let me just do it this way so that you get it perfectly well. Then b1 would have given us 8 over w. Then we move on to b2. For b2, we have that this will be 1 over 2w into 2 minus 3 minus 5 cos. Now again, n is now to 2 times 180 give us 360 cos 360 degrees. And this will give us 1 over 2w into cos 316 is positive 1. So this would have given us 3 minus 5 times positive 1 will give us minus 5. Automatically b2 would have given us minus 2 all over 2 omega this. We have gotten the first 2 values. Then to get b3 will give us 1 over 3w into 3 minus cos 3 multiplied by 180 will give us 540. Then we have cos 540 degrees. And then this will give us 1 over 3w into 3 plus 5. Because cos 540 will give you negative 1. Are you with me? Then b3 would have given us 8 over 3w. We have gotten the first 3 non-zero values. As we move further to find the remaining 2, we now have b4. For b4, we now have 1 over 4 w into 3 minus cos. Now, guys, what is the value here? The value here now will be what? 4 multiplied by 180. And 4 multiplied by 180 is equivalent to 720. Cos 720 degrees. And then B4 would have given us 1 over 4W into 3. Give us 5 minus cos 720 degrees. And then cos 720 degrees will give us positive 1. Positive 1 multiplied by negative 5 will still give us negative 5. And our final answer gives us negative 2 over 4W. That's the answer for this one. Then we move down to B5. B5 gives us 1 over 5W into 3 minus 5 cos. Now, when we come again to this equation, 5 multiplied by 180 will give us 900 degrees. And then B5 would have given us 1 over 5W into 3 plus 5. Remember, cos 900 degrees is negative 1. Negative 1 multiplied by negative 5 gives us positive 5. And 3 plus 5 would have given us 8. So this will give us 8 over 5W. So guys, we have been able to get the first 5 non-zero values. What we just need to do now is to come back to our general equation that we stated earlier somewhere around here. Okay? Which is f of t equal to summation of bn sine n omega t. Then begin to put in the value of n. When it was 1, when it was 2, when it's 3, 4, 5, just like that, and so on and so forth. So very quickly, we're going to wipe up this part of the board so that we'll solve the remaining problem, and then we are done with this. I hope you are mind blown already. If you are yet to subscribe to this channel, do consider subscribing to this channel. Give us a thumbs up and ensure that you give us a positive comment. All of these things are the motivating factors that will help us do more videos to bless your life. Okay guys, now let's quickly state the values we have. Where where B1 is equal to 8 over W, B2 is equal to negative 2W, B3 is equal to 8 over 3W, B4 is equal to negative 2 over 4W, and B5 is equal to 8 over 5W. If you continue like this on this sequence, this will give us minus 2 over 6W. Then B7 will give us 8 over 7W. Then B8 will give us minus 2 over 8W. This is just how the order of arrangement will be ordered. So from what we have here now, we can deduce a model for even function and as well a model for an odd function. How do we get this done? When we look at the numerator for all the even functions, we find out that they are negative 2. But when we check that off the odd function, we find out that they are 8. So that means I can say that Bn is equal to 8 over nW for odd functions, and Bn is equal to minus 2 over nW for even functions or even values. Are you there? So for whatever we have here now, this is what we have. So for even values, okay, let's put values. Those will be values. Even values. So when we put in even numbers, this is what we have. But when we put in odd number, this is what we have. So that's what we're able to generate B6, B7, B8, just like that. Haven't gotten this, so we just recall what we are asked to look for in A that we are still solving is the Fourier series for the periodic function given earlier, right? And then we stated, after identifying that this was an odd function, we then stated that f of t equal to summation of this n from 1 to, just like that, to b n sine n omega t. So my f of t now, substituting for this, will give us b1 sine, where n is 1. Remember everything here, anywhere you see n, you put 1. Sine n1, n is now 1, so have omega t plus b2 sine 2 omega t, anywhere you see n, plus b3 sine 3 omega t plus b4 sine 4 omega t plus b5 sine 5 omega t. Then just like that, you finish. All I need to do now, in place of b1, I'll put its value just like that. So b1 is known as 8 over w into sine omega t plus b2. Now b2 is coming as negative, so this automatically becomes negative 2 over 2w sine 2 omega t. Then b3 is positive, comes as 8 over 2b 2 over 3 omega sine 3 omega t. Then b4 is coming in as negative, negative 2 over 4 w sine 4 omega t. Then b5 is coming in as positive, 8 over 5w sine 5 omega t plus t finish. This is our answer. You can equally decide to factorize. Say maybe peradventure w is common, pick out w, or you decide to go with, let me take the even numbers and take the odd numbers. We can do that. So for the even numbers now, what is common between the even numbers is 8 over w. So I have, what is common between the odd number, 8 over w, so I have 8 over w. For the odd number, I have sine omega t plus 1 over 3 sine 3 omega t, then plus 1 over 5 sine 5 omega t. This is for the odd function. I just remove what is common, 8 over w, 8 over w, 8 over w. Then I now have minus, open bracket. So since I put in minus here, that the values that will be inside this bracket will have to appear as positive, so that if I open the bracket, they will have to give me back negative. So the first value of this now, what is common between this now is what? 2 over w. So put down 2 over w, open bracket. So if I remove 2 over w here, I'll have 1. I'll then have sine 2 omega t, then plus 1 over 4 sine 4 omega t, then plus infinity. So guys, this is the Fourier series. So guys, this is the Fourier series for this particular function. This is the Fourier series for this particular function. It's as simple as this. As simple as this. So it's just for you to know what you are doing, what you're looking for, and how to get what you're looking for. Very simple, with the principles and the key boundary conditions that I give. Alright? Now, if this is the answer to this, the part B of this question states that we should find the percentage third harmonic. Unlike the first one we solved, we actually looked at the percentage third harmonic. It's the same way if you are to calculate the percentage fifth harmonic, sixth harmonic, 10th harmonic, as the case may be. But let's look at for the percentage third harmonic. And this happens to be the B part. Percentage third harmonic. The model for this percentage third harmonic is equal to B3 over B1 multiplied by 100%. So the question is, what is B3, what is B1? Remember that these are capital letters, quite different from this. So how do I solve for B3? Then you come back to either equation 8 or equation 9, among the equations I gave earlier before we jumped into solving calculations, right? Then We have that Bn is given as the square root of An squared plus Bn squared. Knowing fully well that An is equal to 0 because we are treating odd function, right? So An is equal to 0. So if I have A1 is 0, if I have A2 is 0, if I have A10 is 0, even though I have A1 million, it is still 0. For all A values, they are 0. Are you getting it? Okay, so we have B1 here, will give us the square root of A1 squared plus B1 squared, and everything here would have given us A1 is 0. Then B1 is what we have here as 8 over W. So 8 over W all squared, and our answer will still give us 8 over W. Then B3 this will give us A3 squared plus A3 squared, and this would have given us 0 squared plus 8 over 3W all squared, and this would have given us 8 all over 3W. Take for instance, we want to add percentage fifth harmonic. The same way we are going to solve this, or percentage 7 harmonic. Now let me find B7. B7 will give us something like this. A7 squared plus B7 squared. And this will give us, for all A values, we have 0. And then this will give us 8 over 7 W squared. Remember, we did that already here, we solved for it. Okay? But if even though we didn't solve for it, there is a relationship we have already generated to find it. So when n is 7, put 7 here, you have it correct. So automatically this will give us 8 over 7 W. But now, how do we get our final result here according to the question? Right? I just added this B7, not part of this question. So according to the question, to find percentage third harmonic, we said is B3 over B1 multiplied by 100%. Now the question is, what is B3? B3 is 8 over 3W divided by 8 over W. Are we there? All multiplied by 100. Remember, why I'm using this division is that we already agreed that A over B is the same thing as A divided by B, and it's even the same thing as A slash B. Anyone you want to use, they are the same. So it's division. So because I don't want to have multiple lines covered in just solving this simple problem and to maximize my sheet or paper, then I just decided to go with this so that I can solve this just using one line or two lines. So all I need to do now is to change this using the law of conversion. This will give us 8 over 3W multiplied by W over 8, all multiplied by 100%. W takes care of W, 8 takes care of 8. We have this as 100% over 3. So our percentage 10 harmonic, if we divide 100 by 3, we will have this as 33.3333 degrees. This is the answer to this very question. The same way as when we are asked to find percentage fifth harmonic, this will be B5 over B1 multiplied by 10 to the 100%. And our B5, as we have it there, is 8 over 7W times W over 8 multiplied by 100%. And this will give us W takes care of W, 8 takes care of 8. We'll be sharing 100 by 7. Then we have our result. So guys, at this point in time, I've been able to teach you as promised the principles required to solve problems on Fourier series from beginning to the end. This is actually a complete series that will teach you all you need to know about Fourier series. So guys, I think that I deserve a hand of applause at this time. Oh yeah. So guys, if you are engaged with this content from beginning of this lesson to this point, that means this video, this content has actually added a value to your life. It's actually one of the content you are looking out for on the online space. All you just need to do now, guys, is to help us share this video so that it goes viral. And never forget to subscribe to this channel if you have not done so. And in order not to miss out for our mind-blowing content that will be uploaded hereafter, please turn on the post notification bell so that you'll be notified whenever we upload massive mind-blowing content. So guys, don't forget to like, share, and make positive comments at the comment section. And as well, if you have a question to ask, document that question at the comment section. We will answer your question to your own satisfaction. Guys, at this point, I want you to replay this video for your own advantage if there are parts you do not understand. Thank you for watching. Thank you for following us. Thank you for always being there for us. God bless you massively. And as you watch this video, you will know these things once as for all. The same grace that is upon us speaks for you in the name of Jesus. Thank you guys. Thank you very much. See you guys in our next class where we'll be discussing other topics. But if there are other problems I come across that I need to share on this platform, I will do so on this topic so that you get to learn other things out there related to this topic. Thank you very much. Love you guys. See you guys in the very next class.